Got it. Got it.
What do you have in your March Madness bracket?
Baylor.
Baylor? So you're not completely screwed over yet.
Oh no, my bracket's money right now.
Yeah, I think mine's done pretty much. If it helps, Iowa also is losing.
Good, because I picked Oregon.
15.
Oh, really?
Oh,
are
how
you a
many?
genius? Rather like, I think.
I mean,
He's definitely.
He's got insight.
Insider trade.
Anyway,
not allowed.
so an aqueous solution of hydrochloric acid has a molarity of 0.00321. By the way, welcome to Unit 8.
Thank you.
This is acids and bases. Now, I'm sorry, I completely forgot this. Unit 7 test. It was a little long. So let me explain what I'm going to do, and I'll send you an email recapping this. Here's my plan for the Unit 7 test, because I know there were a decent number of people that didn't finish it or were at the very least crammed for time, right? What I'm going to do, and please listen to my whole statement before you make noises, positive or negative. What I'm going to do is open up a second attempt, but that second attempt is only to be used for the free response questions from 19 to 27. What I mean by that is every single one of your multiple choice sections from last week Thursday is what it is. However, if you would like to use a second attempt to finish or fully attempt 19 through 27, I will allow you to do so. Here's what that means though. If you take the second attempt and initiate it, I'm looking at your multiple choice from the first and your free response from the second. I won't even look at your free response from the first attempt. That make sense? No, like on the free response stuff?
Yeah.
No. No. It'll be slightly modified. So the questions, the free response questions will be slightly modified. I have not opened this up yet. I wanted to talk to you first before I open a second attempt, and all of a sudden it's like, people taking it that shouldn't be taking it, or people taking it that don't want to be taking it. Yes. No, you should not. Yes. So literally what I'll do is I'll open it back up. You will have 30 minutes. Well, maybe. I'll see how I time it out. But you will have a second attempt. That is to be used only on questions 19 through 27. Your first 18 are locked. Those are what they are at this point. But if you felt like you ran out of time, didn't have enough time, or were crammed for time, you may take the free response section again. If you don't take the free response section again, then that's perfectly fine. I'll acknowledge what you did for the first time. Because there were people that finished. There was people that didn't need that extra time from last week Thursday. So if you don't even acknowledge the second attempt, that's cool. I have everything you did from the first attempt. The second attempt is only for those people that felt like they didn't have enough time on the free response. And again, if you take it a second time, or if you attempt it a second time, I will not acknowledge 19 through 27 on the first attempt. They will be there, but I will, correct, skip them. Literally skip them. And I will send an email outlining what you should do. I'll put it in the It's Learning notes and stuff like that, what you should do. Yes, skip 1 through 18, go straight to 19 through 27 and do those. Probably Friday, so I can enter the grades Friday.
I was gonna say, those of us who did finish, is there any way we can see updates?
Not prior to the masses finishing up. So yeah, this is going to delay the timing of some stuff, but it is what it is.
Do you want to do it by like Thursday at midnight or like Friday?
Yeah, ideally, again, sometime this week. If it happens on Friday, that's fine. But yeah, ideally sometime this week prior to leaving a break, because I don't want to leave this open after the break, which makes perfect sense. Okay, so, and again, I'll send you an email. If you have more questions on that tomorrow, please let me know. We'll talk a little bit more about that tomorrow if we need to. Okay, so acids and bases. A lot of today is review. Some of it is new, but the vast majority of it is review. You'll want a calculator. And you might want your formula packet, because we got some equations that we're going to acknowledge. 1A says write out a chemical reaction for the dissolution of HCl. Now, dissolution is the fancy word for dissolving. Okay, so we are dissolving HCl in water. We're making a solution of hydrochloric acid. Now, hydrochloric acid, weak, strong or weak? Strong acid. What does that mean? Correct. It breaks apart 100%. So my HCl in its pure form is actually gaseous. I wouldn't expect you to know that, but it is. So if this is the HCl in the pure form, after I've dissolved it, what I get is dissociated ions, right? H1 plus and OH1 minus. Okay. Old news there, nothing new, right? Oh, what am I doing? Sorry. Sorry, I'm just making up science. Let's try that. Look better? Okay, good. So now, let's solve for the pH of this solution. pH, we have a formula for. You did this last year. This was pre-break. Okay? On the front of your note sheet, you see that little grid on the note sheet we're working on today. Sorry, I'm holding this up, but I don't need to be holding that up. On 8.1, that grid, that looks familiar, right? That thing is nice. It has every equation, and it even gives you like the direction you're going, and it's really, really friendly. What you get this year is these equations just in kind of like a hodgepodge order. Okay? So in your formula packet, under the first, on the first page of the formulas, under the equilibrium section, if you go about 2/3 of the way down, you should see pH equals negative log of H1 plus. All right? That's what we want to use here. I want to solve for the pH of this acid solution. So I know that the pH is the negative log of the molarity of hydrogen ions. What's the molarity of my hydrogen ions in this problem? It is. How do I know that? Well, it says the molarity of HCl is that, right? But HCl is strong, right? In other words, 100% of it breaks apart. So if my molarity of HCl is 0.00321, that must mean that I end up with 0.00321 of that and 0.00321 of this. Sound familiar? If we did an ice table, we could do an ice table. It'd be really boring, but we totally could. This would be like 0.00321 minus 0.00321, 0. This would be 0 plus x, 0 plus x, and then x would just equal 0.00321. Sound familiar? Okay. So let's take the negative log of that then. Let's solve for pH. What do you get for a value of pH? .49. 3. How many sig figs is my value of pH? How many sig figs is this number? You're wrong. You're wrong. It is 3 sig figs. Let me explain. This is really funky. Hold on. No, you didn't do this last year. Okay, so with pH and pOH, these are logarithmic scales. What that means is the value out front is kind of just like, it's not a placeholder, but it's just like it kind of just shows you where you are so to speak, in the scale, but they are insignificant values. What I mean by that is when you solve for pH or POH, the leading numbers or the numbers prior to the decimal place are insignificant. It's rather dumb, okay? And I know you don't like that. And at the end of the day, I'm really not going to be picky on it. But do be aware that in terms of significant figures, the numbers prior to the decimal point of pH and POH are insignificant. That is actually 3 sig figs. We only acknowledge the digits after the decimal in a logarithmic scale.
So you can see the number literally anywhere else.
Correct. If it's not a pH and that's the way it was written, it would be 4 sig figs.
Why do you write 2 then?
Well, because we still need to know where on the scale it exists. If I know, okay, I understand. I acknowledged it was kind of dumb. Just is the way it is. If it's pH or POH, post.
That makes you weird. I don't like it. Not you in particular.
I felt personally attacked, but
Sorry.
yes, here's what I'll say. I understand that that's weird. I don't really harp on it too hard, and neither does AP. But do be aware that this is 3 sig figs. As weird as that sounds. Okay. Next thing's next. We also want to solve for POH. They asked for the POH. Now, if you're looking at the little grid, right? That was so nice. Because each corner represented like a different value. And in order to solve from one value to the next value, there was an arrow like telling you what you needed to use. So there was almost no thinking that needed to be done. It was. You don't get this year. No, because that's just the way it is on the AP test. What you get is those same equations, just in a list. And you've got to know what context and when to use them. Yes?
So if I draw a box, you put it here. If I just draw that.
How do you get it?
Yeah, on the AP test, it's attached in the front of the packet.
Okay.
And it is what it is. So now, having said that, you can literally write anything on your test. If you want to have a whole bunch of random stuff in your head, get to your AP test and then just like jot a million notes before you start taking the test, that's an option. But if you know it that well to jot it down from memory, you probably don't need to jot it down anymore. Correct. You cannot rip it out of the front of the packet. Really stupid.
Just keep flipping back to it.
Yes.
I'll just take a picture of it.
Did you say just take a picture of it?
Yeah, I know what I said.
Okay. That's, okay.
Take a picture on your phone and look it up.
Now, to get the POH, we have this equation. This is in your formula packet. It is third up from the bottom on the equilibrium section. pH or 14 equals pH plus POH. Now, when it says 14, that's exactly 14. So literally, as many zeros as you want. Okay. So 14 minus that will give me POH. What do you get for a value of POH? How many sig figs is that number?
13.5.
That's 3 sig figs.
13.5.
13.
Well, 2 is not significant, and 11.
Oh my God. Go ahead.
What does the P stand for pH and pH?
P stands for potential. The potential of hydrogen or the potential
So
of hydroxide.
I was thinking like there are no hydroxide ions in there, so it's weird that there's pH.
Yeah, let's.
If it's the potential,
Well-
that makes more sense.
We'll get. Try this one. I don't think you need me. What I'd like you to do is write out a reaction for a base. The base specifically is sodium hydroxide. And then use the molarity of the sodium hydroxide given to you to solve for POH and pH. Go for it. I'll give you a couple minutes to get ahead of it.
So there's not both of those.
There's your reaction. Now, pH equals the negative log of H1 plus. POH, of course, will equal the negative log of OH1 minus. This is in your formula packet. And by the way, if you don't have your formula packet out, I can't strongly recommend enough. You probably want to get familiarized with where these things are, because again, you don't get that grid. That grid goes bye-bye after this sheet. And if you need to solve for pH, POH, OH1 minus, or H1 plus, you have the equations, they're just in a less friendly format. And you've got to get familiar with finding them on here and making sure you know when to use them in which context, okay? I know it's not as nice. That grid is really, really friendly, but this is what you get. So anyway, so let's take the negative log of hydroxide. What's the molarity of hydroxide? Yeah, it's 0.0451. Now, does it tell me that? You got to figure it out. But let's think about it, right? It's a strong base. It's going to fully dissociate. So whatever molarity I have over here will turn to 0 if I did the nice table, because it's going to fully break apart. And then over here, I would have like 0 plus x, 0 plus x, and my molarity of hydroxide would equal whatever the molarity of my base actually is. So let's plug that in. POH equals the negative log of 0.0451. What'd you get for a POH? 346. Cool. And then we still know that we have this equation, pH plus POH equals 14. So 14 minus that's going to give me a pH of, thank you. Now, what I'll caution you about, and I'm sure you maybe realized this last year, when we ask about whether it's an acid or a base, right? Please use the pH scale. Because it's easy to kind of look at that number and all of a sudden your brain's going to flip on you and be like, oh yeah, it's an acid. Look, it's 1.346. Yeah, no, it's not an acid. That's POH, right? POH is literally the exact opposite of pH. So be careful, be on your toes. Please make sure that when you are trying to contemplate whether a substance is acid or base, use the pH scale, because that's what your brain is familiar with, right? So just a word of caution. Make sure you're looking at the correct scale to determine acid or base. Because if you just glance at POH really quickly, very, very good chance you're going to get it wrong. All right, so the first two problems are the types of problems you did last year. We gave you this diagram. Spoiler alert, you're not getting the diagram, like I said. What you get are these equations in here. Now, all of the equations on that grid are on this sheet, okay? If I'm looking at my formula packet, pH plus POH equals 14. Yup, there it is. pH equals negative log of H1 plus. Yup, there it is. H times OH equals 1 times 10 to the negative 14. Yup, there it is. POH equals negative log of OH. Yup, there it is. Now, what isn't there? What isn't there are these ones. But here's the deal. You don't need those. In other words, you can derive them. Okay, hold on, let me go one more for this. Okay, cool. If I want to solve for, okay, if I want to solve for H1 plus, and I was given a pH, this is the equation. I'm sorry, let me go back one more slide. This is the equation that's given in your formula packet. But if I've given this and I want to solve for that, I can use the same equation. I just need to know how to get rid of a log, right? So I can convert this equation into the other equation that's on your grid. If I take, sorry, this is log base 10. So to get rid of that log, I would take 10 to the power of each side, and then I would just carry this negative sign over. So I'm going to get 10 to the negative pH equals the molarity of H1 plus. That is not on your formula packet, but if you're given a pH, you can plug it in here, and again, assuming that you can manipulate logs and feel comfortable with that, it's kind of on your sheet, just not obviously in the friendliest form. Okay. So long story short, everything on the grid is technically in here. It's just that this is not nearly as obvious and clean and friendly. Okay, where was I? All right, so let's take a little tangent for a little bit, and then we'll get back to the pH stuff in just a second. Let's write out the reaction of water reacting with itself. We've done this maybe once or twice earlier this year too. But I have two water molecules reacting with one another, and what I get is H3O1 plus and OH1 minus. Anyone remember the name of H3O1 plus? What are you supposed to treat it as?
Hydronium?
Yeah, it's hydronium. Nice. What is it? Somebody said it. It's acid. You treat this exactly like you treat H1 plus. They are the same thing. H3O1 plus and H1 plus are the same thing. Okay? So this is like H1 plus with a water molecule attached to it. H1 plus all by itself is without the water molecule attached to it. Now, if H1 plus is existing, spoiler alert, it's in water. So with or without the water attached, this is acid. So literally, like, it's almost best to not even think of them as two separate things. They're one and the same. They obviously look different in terms of formula, but they are one and the same in terms of their properties and how they respond and what they react. Okay, so this is called the autoionization of water. This is a reversible reaction. That's why I put double arrows there. Reversible reactions can, of course, reach equilibrium. And we can calculate the equilibrium constant for this reaction. Hey, let's set that up just for funsies. K equals products over reactants, right? My products are H3O1 plus and OH1 minus. My reactants are water, liquid. We don't include pure liquids into our equilibrium constant expression. So what do I get? I get K equals H3O1 plus times OH1 minus. That's what I get. I'll come back to that in just a second. What's the pH of water at 25 degrees Celsius? 7. 368.
That's still messing with my brain.
Yeah, I know. It's okay. Maybe we'll settle. Maybe. Now, if I want to solve for H1 plus, I have a pH. And again, this is the equation I'm given in the packet, right? The equation I'm given in the packet is pH equals negative log of H1 plus. I know pH. I want to solve for H1 plus. If I manipulate this thing algebraically, I can get rid of, yeah, that works too. I can get rid of the log, okay? And the way I would do that is what I'm gonna end up with is 10 to the negative pH equals H1 plus. So if I take 10 to the negative value of 7, what do I get for a molarity of H1 plus? (1.00 times 10 to the negative 7? Okay, that's a molarity, right? So write that down. So this is pure water, yes? pH equals 7. That makes sense, pure water. The molarity of hydrogen ions in pure water are 1.00 times 10 to the negative 7. What's the molarity of hydroxide in pure water? Better be the same thing. Better be, right? Because if it's not, then we're saying that water is either basic or acidic. And that's not true. Water is the definition of neutral. How we doing? Hanging with me so far? Okay. So we know the pH of water is 7. From the pH of water being 7, we've solved for the molarity of the hydrogen ions. And if the hydrogen ions have that molarity, well, then the hydroxide ions must have the same molarity because it's water, pure water. And pure water is neither acidic nor basic. So H and OH must be equivalent. So knowing that H and OH, let's calculate K. What was K? K was H1 plus times OH1 minus, or H3O1 plus times OH1 minus. Now, this gets a special designation. This is known as W. The W, of course, stands for water. And when I say water, I mean water. Water? Cool. Either way, all jokes aside, this Kw is the equilibrium constant for the autoionization of water, meaning water reacting with itself. And K equals products over reactants. Products are H1 plus and OH1 minus, or H3O1 plus and OH1 minus. We know what those are now, don't we? They were 1 times 10 to the negative 7. So Kw equals that times that. Yeah, you can square it, that's fine. Same thing, right? What does Kw equal? Hopefully that. That's in your packet. That's one of the equations. We never showed you where the heck that came from last year. But when we said OH times H equals Kw, or H times OH equals 1.00 times 10 to the negative 14, we just gave you that equation and never explained it. That's why. Huh? Not knowing the explanation?
Yeah.
Well, then you're really going to have fun in the next 10 minutes.
Oh, yes. I'm listening.
Good. Okay, so let me recap, right? That all makes sense. Water reacts with itself. When it reacts with itself, you get H3O1 plus and OH1 minus. The K value of that equals H times OH. If it's water, pH is 7. Therefore, molarity must be 1.00 times 10 to the negative 7 for both. You multiply those together, you get 1.00 times 10 to the negative 14 equals Kw. And by the way, like I said, that's in here. About halfway down, Kw equals H times OH, which also equals 1.0 times 10 to the negative 14. And then it says, at 25 degrees Celsius. That's the disclaimer. Which of course then raises the question, what if we're not at 25 degrees Celsius? Hey, that's a K value, right?
Yeah.
What changes a K value? Temperature. Wow. I know. That's old news. This is what we had done on the previous couple slides, right? Now, if we're at 0 degrees Celsius, the Kw of water is actually 1.14 times 10 to the negative 15. If we're at 35 degrees Celsius, the kW of water is 2.09 times 10 to the negative 14. It's moving because we're changing temperature. The value of K changes depending upon the temperature. This is an equilibrium reaction. So temp changes, K changes. Let's talk about this. If I want to solve for the molarity of hydrogen ions at 0 degrees Celsius, let's think about how we would do that. What I know is that K equals H times OH, right? Now, if it's pure water, are these going to be different? No. So in other words, if I want to solve for the molarity of H1 plus using the kW, what should I do with that number? Take the square root of it, because H times OH are both going to be a value of X. So X squared equals 1.14 times 10 to the negative 15. And if I square root that, what do you get? So 3.38 with 3 sig-figs? Times 10 to the negative 8, right? Cool. How do I solve for pH? pH equals negative log of that. pH equals the negative log of H1 plus. So take the negative log of that. What do you get for a value of pH? Seven 7.472 with 3 sig-figs. Okay, let's take the square root of this one then. Let's solve for the H1 plus at 35 degrees Celsius. Okay, I know you're maybe chipping away at this. I kind of going a little quick, so I want to try to finish this before we call it a day. At 0 degrees Celsius, water has a pH of 7.472. At 35 degrees Celsius, water has a pH of 6.840. At 40 degrees Celsius, water has a pH of 6.767. Exactly what that means. Is water basic? Is water acidic? No, it's literally not. That water is the definition of what neutral is. So what's with that? Or what's with these? What does that mean? They're neutral. The pH of neutral depends upon temperature. At 25 degrees Celsius, a pH less than 7 is acidic, a pH greater than 7 is basic. If I have a temperature of 40 degrees Celsius, a pH less than 6.767 is acidic, and a pH greater than 6.767 is basic. Water is neutral. It's just that it depends upon the temperature. Kind of weird. Now, at the end of the day, when we solve for pH or pOH or any of these things, what temperature are we going to be dealing with? 25, like universal. So, am I really going to use this per se? No, not really. But do you need to know that it exists and that it happens? Yes, you do, because AP might just sprinkle this information in every now and then. Okay? Let's try to do one more slide. So what is considered neutral at 35? What is considered neutral at 40? What's the trend? As temperature goes up, what happens to the molarity of H1 plus? Yeah, it increases. That's this column, right? So temp's going up, the molarity of H1 plus is going up. What's the trend? As temp goes up, what happens to the pH? Down, right? Goes down. Now, be careful. Is it becoming more acidic? No, it's not. It's literally still neutral. It's water. It's just that we're shifting what neutral means, or the definition of what neutral is. So is the autoionization of water endothermic or exothermic? As temp goes up, okay, as temp goes up, the molarity of H3O1 plus goes up. Where's the energy term? Temperature is increasing. As a result, this reaction would shift, right? And as a result of that shift, I'm getting more H3O1 plus or H1 plus. So where does the energy term have to be? Endothermic or exothermic? Will? It's got to be endothermic. Let me explain. We increased temperature, right? As a result of that stress, which way did it shift? That away. And when it shifts towards the products, we're getting a higher molarity of H3O1 plus. It's a Le Chatelier's principle question, basically, right? So energy went up, we shifted to the right. Now, when I shift to the right, the molarity of the H1 plus will increase. What happens to the molarity of the OH1 minus? The molarity of the H1 plus went up. What happened to the molarity of the OH1 minus? Yeah, it has to go up. They have to be the same, right? Because that's water, and that's neutral. And if I have different quantities of H1 plus and OH1 minus, well, then it's not neutral. Then it's either acidic or basic. But this is water. And in that instance, we must have equal quantities of H1 plus and OH1 minus. Now, so this is endo. This is literally where I got last hour. And they had no safety car. Yes, they will, and they asked a lot of questions, which was good, but there was a lot of questions. So what I'd like to do is I am not going to go over this tomorrow to start class. Here's why. This is last year's stuff. Yes, now when I say you should know it, that's in two senses. You should know it past tense, as in this was done last year, or you should know it moving forward. Both of those things should be true. So please try this. It's not like homework, I guess, but at the same time, I strongly recommend you know how to do this stuff. Please grab a wipe, sanitize. Thank you for your attention. I appreciate your time. And Oregon beat Iowa. My bracket is still perfect-ish. Way better than anyone else's in my pool.
Knocked it down by 3.
Who is? Oh, I don't
We were down
care.
by 8 at one point.
That's just going to help me.
Yeah.
So only have 14 or something.